IGCSE Computer Science. Syllabus Statement 1.1.2a. Represent integers as hexadecimal numbers. So, familiar with the binary system and the decimal system. Binary is base 2, decimal is base 10. So now we're introduced to hexadecimal. Now hexadecimal is base 16. So this means that 16 different values are used to represent each digit in a hexadecimal number. And we also need to know that hexadecimal is closely related to binary. So we're going to look at all of this in this video. In the next video, we'll look at how hexadecimal can be used, why people would use it. Yeah. So 16 different values are used to represent each hexadecimal digit. So what are they? Well, 0 to 9 gives us 10 different values. A to F, using letters now, gives us 6 different values. So if we put them together, we get 0 to F, which gives us 16 different values. So an example of a hexadecimal number would be 2D. To better understand this, here's a table. The decimal number here, hexadecimal number here. So we'll take a look at it. Now, if we go down to 9, you'll notice that they're the same. But then when we go down to 10, well, we can't create another digit to the left. Because if hexadecimal is base 16, it's going to need to have 16 different values for every digit. So that's when we need to start using letters, like A, B, C, D, E, and F. Now, since it is base 16, and only 16 different values can be used for each digit, we can't go above F. We can't go to G. So what we do is when we need to add 1 to the hexadecimal value of F, which is of course the decimal value of 16, then that's when we need to add the left column. That's when we need to increment it by 1, which means that 16 in decimal would be 10 in hexadecimal. And again, we'll look at this when we actually convert decimal and hexadecimal numbers. So how are binary and hexadecimal closely related? Well, binary is base 2, and hexadecimal is base 16. And if you'll notice, 16 is a multiple of 2. 16 is 2 to the power of 4. Therefore, 4 binary digits are equivalent to each hexadecimal digit. And of course, to better understand this, we have a table here. So we have the decimal, hexadecimal, as you've seen previously. And now we have binary. Now, if you'll notice, the lowest hexadecimal digit value that we could have is 0. And that's equivalent to 0 in binary. The highest value, the hexadecimal digit, is F. If you notice, is 1111 in binary. Now that's 4 bits filled with 1s. Now this can make it easier, and as you'll see in the next few videos for hexadecimal, we're going to see that perhaps binary could be represented as hexadecimal, and it may be easier for programmers to use hexadecimal rather than binary.